Nico. Done. Hello, welcome once again and very good afternoon. The lecture number 3 of the mole concept we are going to start. Yes, the lecture is started. So let's start with the very simple part, which is just a minute. So today what we are going to do, we are going to understand the stoichiometry in the reaction. So this is a very important concept and we will deal in this complete lecture about the stoichiometry and we will try to figure it out, what does it mean and how it works, how it helps to reaction to proceeds. Yes, the stoichiometry helps in the reaction proceedings. Okay, so let's start. Let's take a very simple example. 2a plus 3b giving 4c plus 5d. A and B, let's say these are the reactants. Of course, this side is called as reactant and these are called as product. So we have reactant and we have product. So let's say if we will move forward and try to understand these things, we have these numbers 2, 3, 4 and 5. So what are these numbers? These numbers are actually called as stoichiometry. Now what is the importance of these stoichiometry? Actually they helps in the reaction. We can understand how the reaction is taking place. So what is the importance? We can understand how the reactions are proceeding. Reactions are taking place. Now what is the significance of these stoichiometry? Let's look at here. So what does it means when we have 2a and 3b? It is saying that what information we can extract from here. The information is that 2 moles of A required 3 moles of B. In the last class we have understood in a detail what is moles. Moles is the way to measure the chemical substances. So yes, now what information I have in my hand? I have the information that 2 moles of A require 3 moles of B to happen for this reaction to be completed. So for the completion of this reaction we require 2 moles of A to reaction with the 3 moles of B. Now what another information I can have? I can have another information that 2 mole of A will produce this 2 mole of A will produce 4 mole of C. 4 mole of C. Similarly, I can also write one more thing that 2 mole of A will produce 5 mole of D. So these are the information which I can extract by looking into this reaction. So once again look into these information very carefully. So firstly this 2, 3, 4, 5 are the what? These number are the stoichiometry. And we can understand how the reactions are taking place with the help of these stoichiometry. Now what information I can extract from this reaction? So the information is this 2 mole of A for reaction required 3 moles of B, or I can say in the respect of B that 3 mole of B required 2 mole of A for this reaction to be completed. Okay. Now on the other side, in terms of product, what information I can have? The 2 mole of A will produce 4 mole of C, and similarly 2 mole of A will produce 5 mole of D. In similar way, we can write in with the respect of B also. How? Let's say we can write in that way that 3 mole of B is going to produce 4 mole of C. 3 mole of B is going to produce 5 mole of D. So these are the information which we can extract by looking into this reaction. So today we are going to understand how these chemical reactions are taking place, how the product formation is taking place. So we will understand by slowly. So let's move forward into the next concept. Let's try to understand the stoichiometry and the limiting reagent. What does it mean, limiting reagent? So as the name suggests, limiting reagent, which is going to limit the reaction. So it is, we can generally say it is going to limit the reaction, or it is the limit for the reaction, that if this reagent is finished, the reaction is going to be finished. There is no other further formation of the product. Now, how? Let's try to understand. The product is always decided by the reacting amount of the reactant. Of course, if the reacting amount, the reaction we have, let's say this reaction 2A plus 3B giving 6A 7D, and we are saying that only 10 mole of B is reacted. So remember, the reacted amount is only going to give the information about the product. Mark this sentence, that reacting amount of the reactant, reacting amount of the reactant is going to decide the product, or is going to give the information about the product. Now the product can also be decided by the limiting reagent. The product formation can also be decided by the limiting reagent. We will see how to identify the limiting reagent. Here I have the small trick you can find by using this. Janani, hello beta. Okay, so now hello students. So let's move forward. Now in this, to find the limiting reagent, divide the given moles with their stoichiometry. The least value of ratio is limiting reagent. What it is saying, that you have given with the amount of the compounds and you need to divide by them with the stoichiometry. How? Let's see. Okay, I am just making this question to all of you to understand. Let's say I have 2A plus 3B and giving C plus 2D, and at time t equal to 0, be careful, today we are going to understand how the reactions are proceeding. Okay, how the reactions are proceeding. Now at time t equal to 0, I have A, let's say 10 mole, and B I have 6 mole. Now the question is, the first question is find out the limiting reagent. Question first part is find out the limiting reagent. How will you find out the limiting reagent? So the trick is, to find the limiting reagent, divide the given moles with their stoichiometry. What I need to do? I need to divide them with their stoichiometry. So I will divide them. 10 divided by 2, 10 divided by 2, and 6 divided by 3. So it will be 5 and it will be 2. This is 5. So what it is saying, the least value of ratio is limiting reagent. So which is the least value? This is the least value. It is only 2, it is 5. So B is the limiting reagent. So very simple way, how you can calculate it? So what you need to do? Just write the number of moles and divide those number of moles with the stoichiometry, and you will get this. And the least value is the limiting reagent. I hope till this point you all are clear with this. How will you do and how will you calculate the limiting reagent? Let's see the next part. Now see how the reactions is proceeding. how the reactions are taking place. We have, let's say, 2A plus 3B and giving 4C plus D, and I am writing the question. First is find the limiting reagent, second is find the amount of C formed, and third is find the amount of D formed. So we have these three questions. First is we need to find out the limiting reagent, second is find the amount of C formed, and the third question is find the amount of D formed. So in this case, what we are going to learn, we are going to learn how the reactions are taking place. For that, we are going to take the help of these stoichiometry. How? Let's start it. So first is find the limiting reagent. Let's say at time t equal to 0, in the question it is given that it is 4 mole and it is, I would say, is 9 mole. So for the limiting reagent, what you need to do? Just divide it by 2, it will be 2, divided by 3, it will be 3. So this is the least number, so A is the limiting reagent. A is the limiting reagent. Now, what I want to do now, I just want to proceed this reaction. How I will proceed this reaction? So in this carefully, I have A is reacting with B. What I am writing? A is reacting with B. What I am saying? Listen carefully. I am saying that A is reacting with B. So what information I have? So I will use the unitary method. This method is called as unitary method, which I am going to tell you. Unitary method. Unitary method. You must have done in the class 3rd and 4th when we do the questions based on the 1 pencil have the rate of the 10 pencil is 20, so how much rate will be for the 5 pencil. Similar like that, unitary method. So A is reacting with B. So how much A we have? From the stoichiometry, 2 is reacting with 3 mole of B. So this information I can extract from by looking into the reaction that 2 mole of A is reacting with 3 mole of B. I think, is there any issue till this point? If you have any issue till this point, just let me know. Any issue till this point? Now I can write it in this way. A to B. 2 mole of A require 3 mole of B. So 1 mole of A will require 3 by 2 mole of B. And how many mole I have? I have 4 mole of A. So 4 mole of A will require 3 by 2 into 4, which is equal to 6 mole. So the information now, what information I have? I have the information that this 4 mole of A is going to react with 6 mole of B. Once again, try to understand what information I have. I have the information that 4 mole of A is going to react 6 mole of B. 4 mole of A is going to react with 6 mole of B. And how much mole of B we have in the reaction? 9 mole. That means it is present in excess. We only require for the 4 mole of A 6 mole of B. But we have how much? 9 mole. That means it is present in excess. Present in excess, my dear student. This is present in excess. So what will happen? This 4 mole will completely react with 9 mole of this. How? Let's see in this. I can write this reaction once again for all of you. 2A plus 3B giving 4C plus D. I have this 4 mole, this is 9 mole at time t equal to 0. Okay, just a minute. And now at completion time, what will we have the information? So when the reaction is completed, this 4 mole is completely going to react with 6 mole of B. So this 4 mole is going to react completely 6 mole of B. 6 mole of B. So the information we have, this 4 mole is completely reacted. So it will be now 4 minus 4, which is 0 and 3. So after the completion of reaction, left amount of A is 0, left amount of B is 3 mole. Now if I will say we need to decide the product formation of C and D, till this point what we have done, we have understood that how we are going to, how A and B are going to react. So we have till this point understood how the A and B are going to react. So now let's see, we want to make the formation of C and D. How we are going to form this? So let's see what I have now. So the reacted amount of A. So remember, product formation. How to do the product formation? There are 2 points for the product formation you must understand. First point is, product formation can be done by the limiting reagent. Second is, product formation can be done by the reacting amount. So can be done by the reacting amount. Reacting amount. This can be done by the reacting amount. Now let's see how to do it further. So we know A is the limiting reagent, you can do by this, but I want to tell you with the reacting amount, that will be a more interesting. So let's see, I want to make B to C. I want to make B to C. If you want to make from A, that is also fine. So I will write both. Let's say B to C formation, and I will write also A to C formation. Of course, C is same. C is same, so the answer is also gonna be same. So let's see. So till this point, if you have any doubt, just let me know. Till this point, if you have any doubt. Okay, so let's see how will you do. So now B to C. So we have the information 3 mole of B reacts with 4 mole of C. So I can write 3 mole of B reacts with 4 mole of C. Now 1 mole of B will going to make 4 by 3 mole of C. How much mole of B is reacting? Be careful what I am saying, that I am saying the product formation is done by the reacting amount. So this 3 mole, left amount of 3 mole is not reacting amount, it is the amount which has not reacted. So the only amount of B which is reacted, 6, this 6. So I can write reacted amount of B, reacted amount of B equal to 6. Reacted amount of A is 0. So these are the reacted, A, for the A it is 4. For the A it is 4. Reacted amount. So this completely 4 mole of A is reacted with the 6 mole of B. That's why the reacted amount of A is 4 and reacted amount of B is 6. Now let's start with here. So we have 3 mole of B is reacting with 4 mole of, it is forming the 4 mole of C. So 3 mole of B is forming the 4 mole of C, which information we have extracted from the reaction. We have extracted this information. Now 1 mole by the unitary method, 1 mole of B will going to form 4 by 3 mole of C. Now how much mole of B is reacted? Only 6 mole is reacted. So 6 mole is going to form 4 by 3 into 6, which is ultimately going to be 8 mole. So I can clearly write that C is going to form 8 mole. So how much mole of C is going to form in this reaction? 8 mole of C is going to form in this reaction. Now let's try to find out A to C. Do it and let me know. So similarly, this 2 mole of A is forming 4 mole of C. So 2 mole of A is forming 4 mole of C. 2 mole of A is forming 4 mole of C. So I can write by the unitary method, 1 mole of A is going to give 4 by 2 equal to 2 mole of C. How many moles of A is reacted? Or I would say reacting amount of A. So what is the reacting amount of A? Reacting amount of A is 4. So I can write 4 mole is going to make 4 into 2 equal to 8 moles. Similar. So it doesn't matter whether you are using the A or B, you should only focus on the reacting amount of the reactant, and then you are going to get the formation of the product, how much amount of the C and D will be going to form. Okay. So let's move forward. In this regard, we will see next question. Okay. You can just calculate the D also. I am just letting you know D will be A to D. So 2 mole of A is forming 1 mole of D. 1 mole will make 1 by 2. 4 is going to make 1 by 2 into 4 is 2 mole. So D will be 2 mole. You can just try it by B also. You can just get this answer. Now I am just giving you one good question, and I want you to do this question. Okay. Just try it. I have, let's say, this reaction, and it is forming 2 ammonia. Okay. So it is saying that we have initially, let's say, this is 1 mole, and this is I would say, let's say this is 2 mole, and this is 6 mole. Okay. Find the amount of ammonia formed in gram. Just do it. Tell me how much amount of this ammonia is going to be formed in gram. Calculate it and let me know the answer. Try it once. Tell me the answer. Okay. So have you tried it? Write your answer in the chat box. Okay. So let's see how to do it. So we have nitrogen and hydrogen to react. Nitrogen and hydrogen are reacting together. So we have 1 mole of nitrogen forming 3 mole of hydrogen. 1 mole of nitrogen is forming 3 mole of hydrogen. Now this 2 mole of nitrogen is going to react, or it will require 3 into 2, which is equal to 6 mole of hydrogen, which means we have the exact amount. That means after the reaction at time t equal to 0 and time of completion of the reaction, we will have nitrogen left 0, hydrogen left 0, because we can clearly see that 2 mole of nitrogen is going to completely react with the 6 mole of hydrogen. So there is no amount of nitrogen and hydrogen is going to left behind in the reaction, or there is no reactant left in the container. 0. So this reaction is going to be complete. Now let's try to understand how to calculate the formation of the ammonia. So you can calculate by the nitrogen also, the formation of ammonia, or if you want to calculate from the hydrogen the formation of ammonia, you can also do that. So what is the first information you can extract from here? What is the first information? The first information is that by looking into the reaction, you have the information that this 1 mole, by looking into the stoichiometry, the first step you get from the stoichiometry always. That is the importance of stoichiometry. So that information is this 1 mole of nitrogen is going to form 2 mole of ammonia. So 1 mole of nitrogen is going to form 2 mole of ammonia. This is the first information we can extract from this reaction by looking into the reaction, that 1 mole of nitrogen is going to form 2 mole of ammonia. Then my dear students, how much mole of nitrogen I have? 2 mole. So 2 mole is going to form 2 into 2, which is equal to 4 mole of ammonia. Similarly, we can try with the hydrogen. Just try it with the hydrogen. Are you getting the same answer? Just do it once and let me know. Okay. See, how will you do this? Stoichiometry. So how will you do this? We have hydrogen and ammonia. So we have 3 mole of hydrogen and reacting with 2 mole of ammonia, forming the 2 mole of ammonia. So 1 mole of hydrogen will form 2 by 3 mole of ammonia. And if I will say further, how much hydrogen we have? We have 6 mole hydrogen. So 6 mole hydrogen is going to make 2 by 3 into 6, which is actually 4 mole. So you can convert this mole into the weight in the gram. You can convert. How will you convert? So you know number of moles equal to weight upon molecular weight. So ammonia is nothing but 14 plus 3, which is equal to 17 gram per mole. So just convert the weight equal to number of moles into molar mass or molecular weight. We have number of moles. How much number of moles? 4 mole is formed and the molar mass is 17. So 68 gram of ammonia is going to form. So we are going to make 68 gram of ammonia is going to formed in this reaction, or 68 gram of ammonia is going to liberate in this reaction. Is there any doubt? Till this point, if you have any doubt, just let me know. Till this point, if you have any doubt, just let me know, then we will move forward. Okay, so let me know any doubts in this question. Okay, so now let's see further. So now let's see one more question. I hope you can do this. So we have question, let's say I am saying that AgNO3, not AgNO3, let me make it little easier job for all of you. Hydrogen and oxygen is reacting and it is forming 2H2O. Okay, and you have given with the 4 gram of this and 8 gram of this, and it is asking how much water is going to form. How will you do this question? Can you try it? You must tell me the amount of water is formed in this reaction. How much amount of water will be formed if this reaction is going to be completed? The amount is given in the gram, not in the number of moles. So try it once and let me know. Okay, so how will you do this? Firstly, I will tell you, or I will suggest to all of you that convert them into the number of moles. How will you convert them into the number of moles? So we have hydrogen, the molecular weight or molar mass of hydrogen is 2, molar mass of oxygen is 16 into 2 equal to 32. So I can just convert into the number of moles. So time t equal to 0 divided by 2 is 2 mole, and it will be 8 by 32, which is equal to 1 by 4 mole. And if I would say find the limiting reagent, how to find the limiting reagent? Just divide by the stoichiometry. So 2 divided by 2, 1 by 4 divided by 1, which is equal to 1 by 4. So which is smaller? This is smaller. So this is the limiting reagent. So in this case, oxygen is limiting reagent. And remember, the limiting reagent is going to react completely in this reaction. So always in any reaction, limiting reagent means it is going to react completely in the reaction. It will react completely in the reaction. So my dear students, let's see how to do it further. So this is the limiting reagent. So I can do directly with the oxygen to the water. So from the stoichiometry, I have information 1 mole of oxygen is going to form 2 mole of water. And how much oxygen I have? 1 by 4 mole. So 1 by 4 mole of oxygen is going to make 2 into 1 by 4, which is the half mole of water. So we are going to make half mole of water. If I want to convert into the weight, how I will convert? So weight equal to number of moles into molecular weight. So number of moles is half, molar mass is 18. You must know 16 plus 2 is hydrogen is 18, which is equal to 9 gram. So how much gram of water will be formed? 9 gram. Very easy. You can do it. I think you must do these type of questions. So this is the importance of the stoichiometry. By using the stoichiometry, we can tell how much weight of the product, how much mole of the product, or the reacting amount of the reactants. We can predict the limiting reagent. So this is the importance of the stoichiometry. So whenever you don't balance any reaction, be careful. Balance the reaction, because the stoichiometry have the very great importance in the proceeding of the reactions. Now let's see, we have a very good question here. Can you try it? So polythene can be produced from the calcium carbide according to the following sequence of reactions. So calcium carbide reacts with water, calcium oxide, and this is called as, at this age you must understand, this is the acetylene. No need to worry about this. Hydrogen reacts and it will form C2H4, and they are going to be make a polymer. So the mass of polythene which can be produced from 20 gram of calcium carbide would be. So how will you do this question? Can you try it and then let me know? Just read this question and what will be your way of doing this question. See, how will you do this? So remember, we have calcium carbide initially and we have water. It is giving calcium oxide and this acetylene. So the information we can have from here that 1 mole of calcium carbide is going to form 1 mole of this. The number of moles, exactly the same number of moles of calcium carbide is going to make exactly the same number of acetylene. So how much number of moles of this I have? So calcium, atomic weight of calcium is 40 and carbon is 24. So total is 64. We have the calcium carbide molecular weight. Okay, you can just try it. Here we have how much carbon? We have 2 carbon. So it is going to be, carbon is 12. So it is 24. So we have 64. So the number of moles is 20. Weight, this weight, kilogram in gram upon molecular weight. How much molecular weight we have? We have 64. So the same amount of this number of moles we are going to make, this is also going to be the same number of moles. Now this 1 mole is producing the 1 mole of this, the same number of moles of C2H4. So C2H2 is reacting with hydrogen to give the same number of mole this. So we are going to have the same number of moles of this. So So this is also the same number of moles. Now we have the final reaction NC2H4 giving C2H4N. How much number of moles? This N mole is going to make 1 mole of this. So 1 mole of this is going to make 1 by N mole of this. How much mole of C2H4 we have? We have this much mole of C2H4. So the number of moles of C2H4 is, my dear student, 20 into 10 to the power 3, 64 mole is going to prepare into multiply by N. So this much mole of polythene we are going to make. So this much the polythene we are going to make in this term, in this way of this question. Now, but it is saying that we need to calculate the mass. So how will you calculate the mass? We have N times this and C2H4. So the molar mass of C2H4 is 24 plus 4, 28 and multiply by N times. So 28N. We have 28N. 28N, this is the molar mass. So this is the number of moles. So weight equal to number of moles into molar mass or molecular weight. So just multiply by this, 20 into 10 to the power 3 divided by 64 into 1 by N into molecular weight is 28 into N. So you can just N to N cancel and you can just solve it, you will get the weight. So very beautiful question. It is a sequential reaction where we have the information 1 mole of this is going to make the 1 mole of this, 1 mole of this is going to make 1 mole of this. So the number of moles which is here is transferred completely here. Then here we have just solved it. Very good question. Which is heaviest? I will tell you what you need to do. Just calculate for all, calculate the mass. So water has the 18 gram molecular weight. So it will be 2 into 18 equal to 36 gram. Solve by it. Gram per atom, just oxygen atom 16. Just solve it by multiplying it. So you can just try these questions, and this is very good question. A hydrocarbon contains 75% of carbon. In the last class we have seen CH4, if you remember, this is the total molar mass is the 16. Total molar mass is 16. So carbon is 12. So percentage of carbon is 12 by 16 into 100, which is 75%. So yes, CH4 is the hydrocarbon which has the 75% of molecular mass or molecular formula. This is the molecular formula which has the 75% of carbon. Okay, so be careful. And this is what till today. So we have for today, we have done a lot of questions and the stoichiometry. So we have deal with the stoichiometry. In the next class, we are going to discuss the application for the stoichiometry, and of course we have seen some application of the stoichiometry, but in the next class we will see the mix-up questions with the stoichiometry and the geometry and a further topic. So this is for the today. Repeat those lectures again and again, and we will meet on next class. Have a good day. Best of luck.